All right. In this video, we're going to be going over solving by factoring. All right, so we'll factor and then we'll solve it. When we say solve, there needs to be an equal sign, right? And at the very end, we want x equals something. All right, now because these are quadratic equations, they're squared, right? The biggest exponent is a 2. There should be 2 answers at the end. Now, sometimes the answers will be the same number, but there's technically 2 answers, all right? And so we're just gonna jump right in with examples here. So the first one I'm gonna do, I'll do 2 today for you. We have 7x squared minus 18x minus 9, okay? Now remember, because we're solving, it's equal to 0, and that will always be on your paper, okay? And we'll do one, the next example, we'll do one where it's not equal to 0. All right, and then we'll talk about that, but we'll do this one first. Now, solving by factoring, right, that kind of tells us we need to factor first. So we're going to factor this side right here. All right, so remember our AC method. We're going to take A, the leading coefficient, and multiply it by C, the constant. So 7 times negative 9 is negative 63. All right, we want to find factors of negative 63 to add to negative 18. Okay, and now it's negative 63, so one of your numbers has to be negative. Let's see, how about negative 1 and 63? Can we ever get negative 18 from those two numbers? Nope. Okay, how about 2? Does 2 divide 63 evenly? No, so it's not a factor. How about 3? We have negative 3 and what's that, 21? Well, negative 3 plus 21 is positive 18. So what if I make this positive 3 and negative 21? Negative 3 times negative 21 is still negative 63, but 3 minus 21 is negative 18. All right, so these are going to be our 2 factors that we're going to use. Okay, and just like from the last video on the factoring, we're going to rewrite negative 18 as these 2 numbers. Okay, so we have 7x squared plus 3x minus 21x minus 9. See how we took negative 18x and we wrote it as a sum of these 2 numbers, right? Remember, I know you all agree with me with this. You all agree that negative 18 is equal to 3 minus 21. Well, do you still agree? Yeah, you should all still agree because all we did was multiply everything by x. Whatever we've done to one side, we did to the other. So this should still be a true statement. So all we're doing is we're taking negative 18x and we're rewriting it as this, right? And that was done in the last video. So I'm gonna erase this. Okay. Now we're gonna group, right? Group the first 2 and last 2 terms. Now this isn't multiply. We didn't just willy-nilly start multiplying. It's still a plus there. All right. Greatest common factor from the first group, right? The biggest number or number and variable that divide these 2 terms evenly. Well, there's no number that divides 7 and 3 evenly, but these both have x's, right? So we can factor out an x. So 7x squared divided by x is 7x. 3x divided by x is 3. We have our plus sign. Okay, now the greatest common factor of these 2 terms, of negative 21x and negative 9. All right, excuse me. Now this is a positive 7x, so we're going to want this to be positive, right? These two parentheses need to be equal. They need to be the same. So we're going to factor out a negative something. The greatest common factor, now there's not an x here with the negative 9, so we can't factor out an x. But we can factor out a negative 3. Okay. Negative 21x divided by negative 3 is positive 7x. Negative 9 divided by negative 3 is positive 3. All right. And these 2 parentheses here, these 2 binomials, hey, they're equal, so we're doing something right. Okay, the reason we want these to be equal is because now they're also a common factor, right? So we can factor out 7x plus 3. If we factor out 7x plus 3 here, we're left with just x. If we factor it out here, we're left with negative 3. Okay, Now don't forget, we still have our equal sign. I should have put that here, I'm sorry. Okay, we still have our equal sign. It's equal to 0. Now the solving part. Okay, remember this is called the zero product property. Okay, the only way to get 0 when we multiply, this is multiplying now, right? It's not plus anymore because we factored out entire factors. So now this is multiplying. The only way to get 0 when you multiply is to multiply by 0. For example, if we have 0 times 4, or 9 times 0, or 9 times 4. Well, you all know 0 times 4 is 0, and 9 times 0 is 0, but 9 times 4 is 36. So the only way to get something to equal 0 when you multiply is one of the numbers you're multiplying by has to equal 0. Well, we don't know if it's this one that's 0 or this one, so we just do both of them. Either one, either factor could equal 0. Okay, so this factor could equal 0 for this whole thing to equal 0. This factor could equal 0 for the whole equation to equal 0. All right, now we're going to subtract 3 from both sides. We're solving for x now. So we have 7x equals negative 3. Divide by 7 both sides. X equals negative 3 over 7 is one of our answers. Okay, and then over here we're going to add 3 to both sides to get x by itself. X equals 3 is our second answer. And there you go. That's solving by factoring. All right, I left my eraser right there on the other board. I'm gonna go get it real quick. I'm gonna step out of camera and I'll be right back. Okay, so let's do another one, but this time it's not gonna be equal to 0, okay? So we're gonna have to set it up differently. Well, we don't set up it differently. We have to start out differently. Okay, we can't just start by factoring. Okay, and that one, where is it at? Right here. So we have 5a squared plus 6 is equal to negative 17a. Okay? So remember, when we're solving quadratics, okay, we need everything on one side, 0 on the other side of the equal sign. So I want 0 on one side of this equal sign. Now personally, I like to keep my leading coefficient, right, the 5 here, I like to keep it positive. All right, so I'm going to keep this stuff over here. I'm going to add 17a to both sides, because if I add 17a, that makes 0, right? Negative 17a plus 17a, that's 0. Whatever I do to one side, I do to the other. So on this side, I should have 0. Okay, now these aren't common terms because this is a squared and this is just a single a, right? So we can't add those together. Right, so that's what we have. That's our this is our standard form. Okay, right, from largest exponent to smallest. 17a isn't common terms or isn't like terms with any of these, so it doesn't get added to anything. It's just 17a by itself. Okay, now that we have it equal to 0, we can factor. Okay, so leading coefficient times the constant, a times c. Well, 5 times 6 is 30. We want factors of 30 that add to 17. Well, let's see. 1 and 30, does that add to 17? Nope. How about 2 and 15? Does that add to 17? Yes. Okay, 2 times 15 is 30. 2 plus 15 is 17. Okay, so here's our two factors. We're going to rewrite 17a as these two factors. So we have 5a squared plus 15a plus 2a plus 6 equals 0. Okay, now you saw I wrote 15a and 2a instead of 2 and 15. I just wanted you to show you it doesn't matter the way you write it. Okay, because addition, right? It's called commutativity. It doesn't matter which way you add. All right, doesn't matter which way you add. Okay. So we're going to group the first two and last two terms. Now we still have a plus sign. We didn't just start multiplying. That's at the end when we multiply. Okay, greatest common factor. Well, 5 and 15 is divisible by 5. So that's a common factor. And they both have a's, right? They both have, this one has 1a, this has 2, so we can factor out 1a. So 5a squared divided by 5a is a. 15a divided by 5a is 3, right? Because the a is reduced to 1. 15 divided by 5 is 3. Greatest common factor of this group, well, we can't factor out an a because the 6 doesn't have an a, but 2 and 6 are both divisible by 2, so we can factor out a 2, and we're left with a plus 3, right? 2a divided by 2 is just a, 6 divided by 2 is 3, equals 0. Okay, now these two parentheses, these two binomials right here, okay, they're equal, they're the same, so that means they're also a common factor. So you can factor out this whole entire parentheses here, a plus 3. When I factor out a plus 3 with this one, I'm left with 5a. When I factor out with this one, I'm left with positive 2 equals 0. Now once again, we're solving, so we're trying to get a by itself. Because this is multiply now, the only way to get 0 when you multiply is either a plus 3 equals 0 or 5a plus 2 equals 0, right? We set each factor equal to 0. Each factor, this one and this one. Subtract 3 from both sides. A equals negative 3. That's one of our answers. Subtract 2 from both sides. So 5a equals negative 2. Divide by 5 both sides. A is equal to negative 2/5. And there's your other answer. Okay, and that's it. Now remember, our biggest exponent, the degree of our trinomial is 2. So that means we should get 2 answers, which we did. Okay, if it was a 3, we should get 3 answers, and so forth. Remember, that's called the fundamental theorem of algebra. Okay, and it's fundamental, so it's probably a good idea to remember. All right, and that's everything for this video, solving by factoring.